Here's a video on the inverse trig functions. On your screen you're looking at three sort of equations here. Each one has a missing angle. And the inverse trig functions are basically sort of like the opposite of the regular trig functions. In other words, we're going to use the inverse trig functions to find these angles that are obtained from the sine. So the sine of what angle equals 0.9945? We'll have to use the inverse to find that angle. Alright, so let's go ahead and try each one. Right, a lot of times your teacher will probably refer to these inverses as, instead of sine inverse, they'll say arcsin. They're the same thing. That little prefix right there just means the inverse. Alright, so what we're going to do is I'll solve each one of these separately. So the sine of what angle equals 0.9945? Well, that angle is going to stay where it is. The sine needs to move over here and become the arcsine, or the inverse sine. 0.9945 goes right here. So we're trying to figure out what angle, when we apply the sine ratio to it, the sine trig function to it, gives us 0.9945. So we go to our calculators, making sure that we're in degree mode. We hit second sine, and then that decimal, 0.9945. And we get about 84 degrees or so. So x is 84 degrees. So that means that if we take sine of 84, we get about 0.9945. Sine of 84 equals about 0.9945. Alright. So let's find the angle that gives us, the cosine of that angle gives us 0.8910. So the x is going to stay. Cosine moves over, becomes the inverse. So inverse cosine 0.891. Second cosine 0.891. And we get about 27 degrees. So if we check that, right, the cosine of 27 should be about 0.891, and it is. Last one. Tangent of what angle gives us 1.8807? So we'll take the tangent over here, make it the arctangent, and we'll plug that into our calculators. Second tangent, 1.8807. And we get about 62 degrees. So the tangent of 62 degrees, if we were to check this, the tangent of 62 is 1.8007. So hopefully you're seeing that, the tangent, and I'll go back up to the first one, the sine of 84 is equal to 0.9945, which means the inverse sine, or the arcsine, of 0.9945 equals 84. Alright, so that's sort of the basics, right? Let's get into some examples. Number one, we're going to do 3 examples here, and then I'll give you some to try on your own. Number one, I'm looking for, obviously, this angle right here that's missing. In order to find that angle, and I can call that angle whatever I want to, let's call it maybe W. To find angle W, I'm given the opposite side. So we need to remember, let's go back and remember our basic trig functions here. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. That's in the intro video if you want to watch that, intro to trig. I'll assume that you know that. So we have the opposite is 14. This, of course, is our hypotenuse. It's across from the 90-degree angle. So which of these functions uses O and H? Well, it's sine, so I'll go sine of the angle equals 14 over 41. Keep the angle where it is. Move the sine over, make it an inverse, and we'll hit in our calculators. Second sine, move this over here a little bit. So we'll go second sine, let me clear this out, second sine 14 divided by 41, and then press enter. I get 19.966. So W is 19.966 degrees. Now in my class, we always round to the third decimal, third digit there. So that's how I'll leave it, just like that. So if I were to go backwards, right, the sine of that, the regular sine, not the inverse, but the regular sine of 19.966 should give me whatever that decimal is, 14 divided by 41. Number 2. Again, we're looking for the question mark. This time, let's call it maybe angle Z. And we are given adjacent, the one that's next to, and the hypotenuse. So which trig function uses adjacent and hypotenuse? Well, that's cosine. So the cosine of angle Z, and remember, anytime you write a trig function, you have to immediately attach an angle to it. Z is our angle. I see a lot of people try to do something crazy like this. Cosine of 44 equals 50 over Z or something. I saw that in some of my students today, actually. But the trig function, the trig immediately gets an angle attached to it. All right, so just remember that. All right, so here we go. Cosine of Z is equal to 44 over 50, which means Z is equal to arc cosine of that same fraction. So here we go. We're going to go inverse cosine, second cosine, 44 divided by 50. Enter. 28.358. 28.358 degrees. So there we go. Angle Z is a little over 28 degrees. That's this right in here. And visually that looks like it makes sense. And last one. By the way, if you wanted to, you could of course find the hypotenuse here if you want to do Pythagorean theorem. You can also, if for some reason, if you want to look for this angle instead of this angle, you can do that and then just use the complement to get that one. But let's just go forward with this one normally, and we'll say, okay, that this is angle P. So to find angle P, I have opposite and adjacent. Opposite and adjacent is tangent. So the tangent of angle P is 36 over 45. Keep the P where it is, move the tangent over, make it an inverse, and we'll enter that into our calculators. So inverse tangent of 36 over 45. Enter. 38.66. 38.66, and that's a degree. So the measure of angle P is 38.66 degrees. And again, if I'm asked to find this, right, I know that the angle P and angle, say, Q are complements of each other. So that one should be, what, 51.34 degrees, I think. 80, yeah, that looks good. And you can find that too if you wanted to. You can say, all right, now I want to find angle Q to check to make sure that this is correct. So I could use, again, tangent of Q is 45 over 36. Opposite over adjacent. So it's all sort of perspective. We're still using tangent, but these two fractions are reciprocals of each other because we're looking at a different angle, looking at the problem from a different angle, literally. So inverse tangent of 45 over 36 should give us 51.34. Let's check. Inverse tangent 45 over 36. 51.34. Yep. And these two numbers are complements. They add up to 90 degrees, which makes sense because this is 90 degrees, and the whole thing should add up to 180. So everything checks out. So there you go. A couple examples there that I walked through on arcsin, arccos, arctangent. Try these 6 on your own. I'll leave these here for you. I'm not going to go through these, but in a second I will flash up the answers for you. So pause it now. Alright, so the answers to these 6, they're not going to be rounded to 3 digits, they're just going to be whole numbers, but it definitely is a good way to check. You know, here we can see that we're going to use cosine, here we're going to use sine, this is cosine, this is sine, this is tangent, and this is tangent. The arc cosine, the inverse of all these. Remember, we're going to use inverses anytime we're looking for angles, and the regulars anytime we're looking for sides. Here are your answers. Check them over. Pause it if you need to go through these, but I'm going to wrap this video up. Just to kind of recap, right, we'll use our inverse functions when we're looking for angles, and we'll use our regular functions when we're looking to find side lengths. That's really kind of like the main difference you need to understand. Inverse trig functions or arc trig functions give you angle measures, whereas the regular ones, the regular sine, cosine, tangent, give you side lengths. So that's probably worth making a note of. Anyway, thanks for watching, and in the future I'm going to go through maybe some more trig videos. I'll probably get into, you know, the unit circle and begin to you know, hopefully broaden my trigonometry playlist. So thanks for watching.